Hi, I'm Stefania Soldini, and today I would like to talk about space mission to Asteroid, how to plan a space trip. Now, I would like you to think about which subject do I usually use for planning a space mission. Now, there are different things we need to do before sending a spacecraft at this target object, and we have to study the solar system dynamics, which means where the planets are at the moment of launch. So this is about kind of a science aspect of my job. So it's celestial mechanics. So think about which subject do we need here to study our solar system. And then we plan a mission to space. So we want to send a satellite, we want to control it, we want to tell you what to do. And then this is a part of engineering, spaceflight mechanics. Now, I usually apply the subject here, which I'm not mentioning, but think about it. And I do numerical simulation. By applying that, I can predict where object goes. So my subject is basically coding. And this is called astrodynamics. Maybe you have seen the movie The Martian, and there is an astrodynamicist. That's my job. So basically, we want to plan a trip into space. It's not as easy as on ground, as with a car, you know exactly where to go by following routes. In space, we don't have those specific routes. So that is the complexity of it. This is example of Hayabusa 2. And this is what an astrodynamicist does, try to find a way, a path to go from the Earth to the object desired. Now, I did this, I experienced myself sending command to a satellite in December 2019, and this was the Hayabusa 2 mission, so that's why I'm so fond of this mission. But the question is, why studying asteroids? So let's go back 65 million years ago. What happened to dinosaurs? Basically, it's almost proved that an asteroid 12 kilometers in diameter has basically caused the end of the dinosaur. So this is due to the fact that we found a crater in the Gulf of Mexico, and scientists proved that could have caused the extinguishing of the dinosaurs. Now, this is those events don't happen often. More often, we have objects that re-enter that are smaller, but they still cause damages. Like in 2013 in Russia, there has been an asteroid of 20 meters that caused injuries and also damages to buildings. So it's very important for us to know when this object re-enter and how we can mitigate the damages as well. So our solar system has formed, this is the most accredited theory, from gas and dust orbiting together that form the protoplanetary disk. Now, the asteroid seems to be some rocks that haven't actually grouped together to form another planet. And so this is a leftover of our solar system. And they're very important to study because asteroids from the main asteroid belt, from time to time, they get close to the Earth and they are called near-Earth asteroids. If they have a big diameter, like 130 meters, they might be considered hazardous. So this is one question for you to think about it. What are the key elements that scientists are looking for in asteroids to explain the origin of life? Can life be brought from outer space, from an asteroid? So that's why we're sending mission to space, is to understand what they're made of and analyze them from ground. So this has been Hayabusa 2, which successfully re-entered sample in December 2020, and now scientists are analyzing them. NASA has done the same, and in December 2023, we're going to have the sample of Bennu. And I have actually a sample of those objects here. This is Ryugu and this is Bennu, 3D printed object. And what is remarkable is the next mission we are planning. So think about binary asteroid system. Now, ESA and NASA want to test our ability to change the path of an object. Like imagine an incoming object impacting the Earth. What can we do to save the Earth from an hazardous asteroid? So first of all, we send a probe on a binary asteroid system, Didymos, and what we do, we impact a satellite, a spacecraft, against a smaller moon to change its trajectory. Now, if we can prove and we can measure that we can do that, then we have developed a technique to protect the Earth from hazardous object. And this is the scope of planetary defense. And part of my role is also to assist ESA and NASA on their project. So thank you for your attention.